by Max and Jean-Baptiste.
Yeah. So, hi everyone. We're gonna present you all the work that have been done to make Faro running on embedded systems. I am Max Maton. I'm working in the AirMod team as a PhD student, and I work on DSU, that is Dynamic Software Update. It's very far away from the presentation, and all the work we're gonna present is Jean-Baptiste's work, but it's quite good stuff. So the presentation will follow this roadmap. We're gonna start with the demos, so you can start to play with the Raspberry Pi while we are doing the presentation if you want. And well, of course I will explain the demo and how it works, and then we're gonna do a quick update on the different status of Faro on the different embedded systems. Well, for the demo we have a Raspberry Pi, which is here, and on the GPIOs we have plugged a Piglo. That is more or less just a couple of LEDs to see what is emitted on the GPIOs. That's just to prove that there is an interaction between the software Faro and the hardware part. So on top of the Raspberry Pi we make Faro run. We use a Piglo to see what happened on the GPIOs, and to interact with it, as we don't have a screen and a keyboard, we use Seaside, which is a web server application. And so we can interact with it dynamically and even use all the benefit of having a live code environment on the Raspberry. So I'm gonna show you that. Up. So this is a sample counter that runs on the Raspberry Pi. And if I try to interact with it by incrementing it, you can see that the LEDs are turning on or turning off dynamically. It's basically a binary counter displayed on the different LED. So I can even use as I said, the benefit of being in a live environment to get directly an access and to the Faro image and execute code right here, in just like in a normal Faro way to do it, a Smalltalk way to do it. So here, for example, if I try to run an example of the wiring P binding, I can execute it, and it's automatically doing this nice little thing with the LEDs. This is a full dynamic environment. It's very cool to bring this kind of coding on the Raspberry Pi, because it brings live coding with robotics quite easily, and it can make the life of robotic developers way easier. Of course, if you have a screen and a keyboard, it's way easier than using the web interface. So if you want to play with the counter yourself, if I can find back, damn it, Keynote. You can connect on the Wi-Fi that is broadcasted using this authentication. Go on this URL, and well, there are already some people that are linking it. That's nice. So now Jean-Baptiste will present the statue.
Okay. Hello everyone, I'm Arnaud Jean-Baptiste. I'm actually the maintainer of the platform ARM for the Faro part language. So, as maybe you do not say know, but Faro and Squeak share the same VM, so it is an environment context that we know. So we push some information together in the same VM, but we have some specificities that like native boost and stuff. And we are different implementation of the same VM on the same language. So. As he presented, so some people already play with the counter, that is cool. So if you're bored, do not hesitate to play, because I usually are really bored speaker. So first explain the Raspberry Pi. So we make all the wow, that is so cool. I have the IP of the people that are doing that, so that is really fun. I will show at the end how many people try to break my stuff. That is quite cool. So basically, the VM Raspberry Pi, as Craig explained previously, is generated in C, and so we need to port it on every platform. So we have now the stack interpreter, that is basically the VM that's using the C-optimized stack, but we do not have the JIT compiler that is main, do not have yet the main compiler, the just-in-time compiler for the standard for the ARM platform yet. So the Raspberry. But once some cool things is appears that some people need another Linux-based ARM platform. And we are being able to port the VM in less than 1 day. So it was just a couple of fixing, and it was so cool. So the platform was Amadeus, doing by the car team. They're doing robotic stuff. It's cool. So now we have the VM. We have a complete build process that publish automatically. So we take the last test source. We take all the toolchain, we construct on the continuous integration platform, we compile it, and we publish the file. In addition, we have integrated slowly all the integration and the relationship with the OS. So OS process have been integrated. We have integrated the FFI stuff. So you can use with the GPIO, no, like that. And yeah, we integrate the GPIO support, obviously. So now you can beginning to bring the software and the high-level software that the Smalltalk language provide to the hardware using direct manipulation, general input, output. So what is now in progress? We want to, because now all the test server are the physical slaves, so that are a big constraint, in fact, because that means if you have a problem, you need to move and take a keyboard and the screen, and you cannot easily reboot it. You need to reconstruct manually. It is really, really boring. So we study the way to simulate everything, and we have already a prototype that's working. So using QEMU that generate everything and run the test on the completely virtualized slave. So that is quite cool, because we can from scratch reset everything, have a T0 state, and retest all the chain at the end. So because for now, if we want to do a T0 each update of Raspberry, we need to update the slave, we need to take care, and that taking time, that taking a lot of manpower, and we want to lighter that. So another project is we try to make Faro lighter for embedded and more specialized for embedded, because embedded have some different constraints. You do not have the same CPU capacity, you do not have the same memory, so we try to enhance the way, and you do not have also every time a UI, and you cannot modify the image using only C-side or web server application. So like we do like that here, but it is heavy, so we try to make that lighter, and that is a bootstrap project, part of the bootstrap project made by Guillermo Polito. So we plan now to have a UFFI, so more unified FFI depending on the platform. So you will redo that and maybe think about integrated low code, I think. Yeah, low code. So that is basically a assembly generator. So we will see, we study the possibility to generate directly ARM from the higher level of the language. So in addition, the JIT compiler is actually developed by Timor-Leste for ARM. And I do not know the statue, but the last time I see it was good advance. Yeah, it was closed a couple of months. So we will have the same JIT compiler as the standard main VM. So that are some useful link if you want to play with Pharo on Raspbian. So that is a link where you get the last SVM that is compiled, and that is where you can find the source of the main Pharo repository if you want to extend it using the CI environment and everything. Okay, and now let's explain a little bit the statue of Android. So for just the record, there are a cool project Android that's working some years ago, but it was not updated anymore because we do not have people that run it, and and the CI was the VM was based on the fork, so it was not updated from the Pharo from the Smalltalk Swig Pharo unit from the redo it. So it was not, it was a fork, so an update in the mainstream do not occur. We need to have a specific people that maintain the Android branch. So here now the objective was to, okay, we basically Android, it is a sandboxing Unix with some specificity. So let's just take the Unix source and make some specificity appear in the Unix source, and after generate from the Unix source and do some small modification to just make it run. So basically it ran. That is 3.0 with event and everything. Well, that's cool. 3.0. So
show me good.
what? Yeah. So that have been done. So the process, the Android native compilation process is not so obvious, at least for me. So I take a little bit time to do that, but one of the biggest issues that I have it is I need to redirect all debug method to the specific logcat message to be sure to not miss any execution transcript stuff, and so we have a lot of fprintf, sprintf in the VM. It's horrible. So I need to just do not considering the VM as a one library and have a separated library, be able to load some share libraries. That's taking time also. We should manage external display because we want at term to have the choice of how you display. If you want to do your own application, maybe you do not want to use the standard displays that basically take a bitmap and draw it. Maybe you want to have some high-level Android application at STEM, so you need to have some separated display and run a 4.0. So, oh no, it is a 4.0. No, that's one is a 2.0. But the 4.0 image one. Also, we done now we're managing all the events. The gesture, it's a little bit blah, but work exactly as the whole version, but we need to think about how manage better the gesture and have a better connection with the Android gesture, because Android provide a good, really good high-level framework for managing gesture. Everything is now merged with the Pharo repository master. Now I need to extract all the things and put in the step upstairs, but it will be done soon. The configuration generator is pushed also. The Jenkins process is working. So we are able to reconstruct completely the Android VM, the Pharo Android VM. Now what we need to have a set of Android primitive to control the VM, the appearing of disappearing of the keyboard, and by example some cool features like okay, I want to have a force an update or call this kind of primitive upstairs. No, we need as the people do not want to just play with the language, they want to do application, so we need to to refine the way that we package everything, to provide a high-level UI using Android. So basically now we just have a proof of concept. Okay, the VM run. We can use the UI of Faro, but now that can be cool because we need to use all the Android infrastructure upstairs. So now it is a good plan, beginning to play with that. So basically it is all. If you are If you are interested, we can show you some Android demo, how that works and everything at term. But as it's hard to show that in presentation, I guess we will do that in private if you are interested. So that was nice. So thank you. And if you have any question. Yeah.
Maybe just one. Is the VM limited to Raspberry Pi, or would it then run on all platforms?
We do not generate. In fact, for now, we. Repeat the question, please. Okay. No, the is not completely limited to. We have some limitation on. Okay.
What was the question?
The question was if the VM is limited to only Raspberry Pi platform, or if all ARM platform is managed. In fact, it's not limited, but it is. I know there are RISC-OS VMs that running, but basically the Raspberry Pi VM that in the way that we compile is basically compatible with most of the Linux ARM platform. We port in fact, it is just after the dynamic library problem. We port that on Amadeus. That is a Amadeus. Yeah, it is that.
Yeah, Amadeus.
Amadeus. It is a platform using in robotic, I guess.
Yes.
Yeah, using in robotic, it is a ARM Arch Linux running on Arch Linux. I cannot remember. And well, we can check after. And basically, it was ported in one day, just changing the leaking of one library, and it was perfectly working. And some people using it now.
So basically,
Yeah.
if it's a compatible platform to Raspberry Pi, let's say ARM v6, running on Linux, then it should work.
Yeah,
Yes.
it should work. Yeah. Yeah.
There are different ARM platforms. Does that work on all different ARM platforms?
What do you mean, the version?
Well, the V6, V7.
V7 is retrocompatible to V6. Now it is I just all the Jenkins process is just compiled on V6, if I remember well.
Yeah, on the Raspberry.
On the Raspberry, yeah, it is a V6. So it is a V6, but V7 is retrocompatible, if I remember. Yeah, it is because.
No, I don't think.
No.
Sorry.
Oh.
That's the magic of having a new computer.
Yosemite magic.
Very
Do you need more power?
No, it is just when he go to sleep, he make 10, 20 seconds. So basically it should be retrocompatible, but I think we can enhance performance if we do a specialized byte for Arch V7, in fact. We can optimize, in fact, the compilation process, but we need to do it. But it is retrocompatible. That work, but we can do better. Yeah.
Did you implement all the I/O of the Raspberry Pi? Just like
Not all the GPIO. For now, we implement in fact the GPIO control using a library called WiringP, and we basically in fact try to just completely implement the access from the library. So it seems that we can read, we can write, obviously. WiringP proposed some specialized binding for example Piglo, and we basically at term what we wanted is to push everything from WiringP. So if WiringP the C library WiringP manage that, I think it is pretty complete. We will manage it, so it should be good. And you can always manipulate it by hand. If you are by manipulate directly the file, open it from Faro, you can do it. You just do sudo and manipulate the file. It's a little bit, but yeah, basically yes.
And it is easy enough about, for example, if I want to have a complete environment, I mean that all windows that I have in my computer, no,
Yeah.
Connected to Raspberry Pi, I can have everything, or just one window.
You cannot. In fact, you have a complete firewall environment. If you have a screen,
Yeah.
if I understand well, you just have the development environment, for example, of Smalltalk, firewall, or Squeak. Basically, yes, because that running, let's say, you just plug it, the Raspberry Pi, that work. It is a little bit slow because it is a Raspberry, but that work. You have a complete environment, in fact.
All windows.
Yeah.
Just like
You can manipulate it.
complete firewall
Yeah.
environment.
Yeah. The only thing that missing previously, it was initially we have native boost in the x86 platform, and we do not have it ported in ARM platform. But now we replace it slowly by the threaded FFI, and you cannot generate ARM assembly. It's not a really common use, but some people want it. So for now, you can use, in fact, firewall image. Standard firewall image.
But the performance is not let.
No, the performance, especially the UI, it's not. But in fact, is not for developing. It is really slow. I do some bug fix, and it is really a pain for developing. But for running code, it's really enough. I mean, C-side run well.
C-side run very well, but there are also some remote debugging solutions that are developed for Faro. So maybe combining this remote debugging solution with the Raspberry Pi might be a very good way to develop.
So I repeat for the mic. Max explained that there are some remote debugging solutions that exist, and that is pretty advanced. No.
I really don't know that. I know there are projects.
There are projects that existing for remote debugging for robotics. So I think you can find.
But the best way to work with, you develop first in firewall.
Yes.
On the Linux platform,
Yes, and after that
you migrate the image, and basically it is the same VM that the Linux one. The only thing that changed is you cannot generate assembly. That is not current use.
load after that to your
Yeah.
Raspberry Pi.
It is what we recommend usually to people. Some people ask for that, and they develop on Unix platform, and just copy the image, and that will work perfectly.
Okay, thank you.
You're welcome. Yeah.
Final question on wiring Pi. Do you use the native GPL ordering of wiring Pi, or do you make a layer on top of it using the GPL ordering of Raspberry?
Wait. Can you speak louder, please? So you ask me if I hear well, but I'm not sure. I try to do some inference. I try to answer that. So you ask me if I'm using directly all the GPIO. I do not get it.
It's about the order of GPIO in and outputs. I mean, wiring Pi has its own order, and it's not one-to-one compatible with Raspberry Pi. So are you using the native ordering of Raspberry Pi for GPIOs, or the ordering that wiring Pi provides?
I do not hear it.
Yeah, when you
Answer.
use wiring Pi,
Yeah.
usually when you turn on the one LED,
Yeah.
it turns on the second LED of the Raspberry Pi because it has its own
Yeah.
order and things. So
But yeah, you have this. Okay, you mean the GPIO pin numbering. Yeah. But it seems that some code for switching exists in.
I'm just asking which kind of order are you using? Are you using the native?
I use exactly the same as wiring P for now.
Perfect, thanks.
yeah, it's just
But it is just an adapter, in fact.
Yeah, sure.
We can just. But yeah, we're using wiring P.
So no additional magic.
Yeah.
thank you very much.
Thank you.